So today's lesson is on completing the square, and this is lesson 9.3 in the book. So I wanted to quickly review. If we have x minus 4 quantity squared, then that is the same as x minus 4 times x minus 4. And if we do the box method, then we can see that we get x squared minus 4x and plus 16. So notice how these two are the exact same, and they add up to this one. Okay. Now we're going to actually practice finding how to, what we call, complete the square. So this 16 won't always be given to us, and we'll need to figure out how to do that. So if we look at our first example, then it's going to be x squared plus 6x, and then plus c. So using our standard form, we've got a, b, and c, okay? So that's why we call this the c term. So if we did the box method, I know that these two boxes right here need to add up to 6x. Now, because this is called completing the square, I know that they both need to be the same. So this x squared goes in here, and two numbers that add up to 6 that are equal are 3x and 3x. Now, if I looked at the GCF of here, we've got x, and the GCF here is also x. But if I just took the 3's and I multiplied 3 times 3, I would get 9. So then I can pull out my GCF here is 3, and GCF here is positive 3. We always match the sign of the box adjacent to it. So this c value is going to be 9. So c would be 9. And then if we took that and we said, okay, what does that factor to? Well, we know that it factors to x minus 3 times x minus 3, which is just, x plus 3, to x plus 3 squared. So let's try that one more time. But this time, we're going to choose a number that's odd, because not every number will divide evenly by 2. So if we do x squared minus 9x, and I want to know what is that c, what's that value, that would help me. Oops. So we can use our box method to say, well, x squared is going to go here, and I need these two values to add up to negative 9x, and they need to be the same. Well, there's no integer that would add up, but I can just take half of it, so negative 9 over 2x, and negative 9 over 2x. Okay, that's basically 4.5, but as a fraction. The reason I left it as a fraction is because it's a little bit easier to multiply them. So negative 9 halves times negative 9 halves is positive. 9 times 9 is 81, and 2 times 2 is 4. So this is going to be 81 over 4. So essentially I'm taking half of this term, and then I'm squaring it, because I'm multiplying it by itself. And so c would equal 81 over 4. And then I could see that this would factor to x minus 9 halves quantity squared. So this negative 9 halves comes back into play right here. All right, so let's do a whole problem using this. So completing the square is a great alternative to the quadratic formula, which we haven't covered yet, but we will cover soon. So let's say we have x squared plus 8x minus 3 equals 17. So in the past, I would have moved the 17 over so that it equals 0, but this time we actually want to isolate these two terms. So I'm going to add 3. Okay, so we want to isolate the x terms. Okay, any terms that have x in them, even if it's x squared. And then we're going to ensure that the a equals 1. So that is referring to the ax squared plus bx plus c. Okay, so this value needs to be a 1. So we have x squared plus 8x. I'm going to leave a blank equals 20. And I'm going to use completing the square to say, okay, x squared's here. These two need to add up. These two need to add up to 8x, and they need to be the same. So that would be 4x and 4x, which means in order to complete the square, we do 4 times 4, which is 16. So I'm going to add 16 to both sides. And I'm doing that to both sides so that my equal sign can still be true. All right, now if we factor this, we've got GCF of x, GCF of positive 4, GCF of x, GCF of positive 4. I get x plus 4 squared equals, and then 20 plus 16 is 36. And so from here on out, it's just the same as what we learned yesterday, where we're going to square root, and we get that x plus 4 equals both positive 6 and negative 6. So I'm going to create a second equation where this x plus 4 equals negative 6. And then I have one more step because I need to subtract 4. We get x equals 2. And I still need to subtract 4, so then I get negative 10. And those are my two solutions. Okay, last but not least, we have one word problem. Okay, so you throw a stone from a height of 16 feet with an upward velocity of 32 feet per second. The function, blank, we're going to fill it in, gives the height h of the stone after t seconds. So h is height, and it's in feet, and then t is seconds. Oh, sorry, time, which is in seconds. Okay, so we haven't gone over how to write the equation of it, but it's going to be height equals negative 16 t squared plus v0 times t and s0. So this v0 stands for initial velocity, okay? And it would be positive if it's going up, or maybe negative if it's going down. And it has a t with it because it's per second or per minute or per time, whatever that is. And then last but not least, we have initial position. And this is our y-intercept, which is the same for a linear function. And that's going to be here. So our initial position is right there. So my equation would be h equals, let's go back through and see if we can find our initial position. You throw a stone from a height of 16 feet. Okay. With an upward velocity, oh, look, there's my velocity, 32 feet per second. Okay. Now, I'm just going to use the values and not necessarily the units. I'm going to make sure that they're the same. So feet, and then I can move on. So my height will be negative 16 t squared. That part doesn't change ever. And then plus 32, because that's my initial velocity, times t. And then plus 16, because it's 16 feet above the water. Okay. And then my question says, when does the stone land in the water? Well, what's the height of the stone when it lands? Okay, the height is 0. So I'm going to set this equal to 0. And now I'm going to come back up and look at what were the rules that we said. So we want to isolate the x terms and also ensure that this is 1. So if I can do them in the same step, we'll try. Let's go ahead and factor out our GCF. I'm going to factor out the negative 16 so that this value can become 1 t squared. So I'm just going to write t squared. This is 0. And then this would be negative 2t minus 1. And now that we have an a value of 1, I can isolate my terms with t. So I'm going to add 1 to both sides. So I get 1 equals t squared minus 2t. And now we need to complete the square. So we need two numbers that add to negative 2t. So that would be negative 1t, negative 1t. And then I take those. Negative 1 times negative 1 is positive 1. So that's what my completing the square is. So plus 1, and that is what I'm adding to both sides. This will factor, so my GCF here is t. GCF here, we match that negative, is -1. GCF here is also t, and GCF here is also -1. So this will become t minus 1 quantity squared, and this is now 2. So then we would solve by square root, and we get the square root of 2, both plus and minus, equals t minus 1. Well, let's split that, and so that we have the square root of 2 equals t minus 1, and we'll leave the negative 1 over here. So if I add 1 and I add 1, I'm going to use a calculator and figure out what is the square root of 2. So it's roughly 1.4. So this is kind of like negative 1.4 plus 1. So this is roughly negative 0.4. And then this one would be square root of 2 plus 1 is t, which is roughly 1.4. So in the context, which one makes sense? We're going to go with this option, or this one would be our exact answer because it has the square root. We're not rounding. This one does not make sense because we would have to go back in time. Okay, that's it for today. Let me know what questions you have when you come to class.